On the back page, there are 3 solving questions. For number 8, tangent to the 4th, we can deal with. We can factor that because that's tangent squared times tangent squared. So, and there's no real true conversion for that. I mean, we could come up with something, but let's not try to get too creative. Instead, let's get rid of that secant squared, and in its spot, put the tangent squared plus 1. So we're going to do this. I'm going to do this whole problem in tangent. I'm also going to bring the 1 over and set it equal to 0. You know you're going to have to factor this one. So distribute the 2. And then move this, rearrange this. So it starts off negative tangent to the 4th plus 2 tangent squared x. And then you have 2 plus 1. So that's your plus 3. I'm going to go through and change all the signs. Of course, you know that's going to happen. So this is positive, negative 2 in the middle, and a negative 3. Tangent 4th is going to be tangent squared times tangent squared. Now there's only one way to get a 3, and that's 3 times 1. To make the 2 in the middle negative, we want to do negative 3 and positive 1. Sorry, that's a plus. So here we get tangent squared x equals negative 1. Well, when you take the square root of a negative number, this is imaginary. And not obviously there's no answer for that. We've never seen that before. Tangent squared x here equals 3. And when you take the square root, you get that the tangent is positive and negative radical 3. So when it's 1, 3, you know it's your pi over 3s. We're in degrees though, and we want 1 in each quadrant. So these are your multiples of 60. 180 minus 60, 180 plus 60, and 360 minus 60, 300 degrees. For number 9, you could factor out a cosine right here. And if you did it that way, you probably got a little bit stuck. Because of the cosine squared, it's probably better to just go ahead and switch that to 1 minus sine squared. Now, if you think about cosine times tangent, I'm just going to make a little prediction here. Cosine, sine over cosine. The cosines are gone. So what's going to happen is we're going to have to put the entire problem into the word sine anyway. So we might as well go ahead and switch that cosine squared. So again, the cosine is cosine over 1. Tangent is sine over cosine. And you really should reduce that. Get rid of some of this extra stuff. Minus 2, and then inside here, cosine squared, of course, is 1 minus sine squared. And we'll again bring the 1 over, like before. So this is all gone. This is just a sine. Distribute the negative 2. Remember, it is a negative 2, so we get minus 2, and then plus 2 sine squared. The 1, of course, is still the 1. Moving this around, we have 2 sine squared x. Then the next is the sine, and that's positive. And we have negative 2 plus 1, so that's a minus 1. 2 sine squared is 2 sine times sine. Only one way to get 1. Well, having the positive in the middle means the 2 that's away from, or I'm sorry, the 1 that's furthest away from the 2 is the positive. And then, of course, we get that the sine of x is equal to positive 1/2. And here the sine of x is equal to negative 1. This is still in degrees. It's positive. Sine is positive in the first and second quadrant. And sine is negative straight down at 270 degrees. Cosine of 2x. You can turn that into a lot of things. And by looking at the first term, it seems like we should use the sine squared. But then we have this. We have this plain cosine. So reality is you can't change that cosine. So we're going to put everything in terms of cosine. You don't have a choice. So we're going to make this sine squared as 1 minus cosine squared. Cosine of 2x, I'm going to pick the one with the cosine in it, which is a 2 cosine squared x. then the minus cosine, still there. Combining like terms, 2 minus 1, so we get cosine squared, minus cosine, oops, sorry, it's 2 cosine squared, I forgot my minus 1. You're probably wondering where that is. It's right here. Sorry, that's from the cosine of 2x, I just forgot it. And then negative 1 plus 1, that's gone. So they add out. This is GCF. They have a cosine in common. Leaves you with cosine of x minus 1. So we get that the cosine is 0 or that the cosine could be 1. Cosine is 0, of course, up and down, 90 and 270. And cosine is 1 at 0. You cannot use 360 based on the way the interval is written. And then don't forget about these. When you have a number that's not a 2 in front of your x, like we have a 5, so the first thing we do is we take our interval 0 to 360 and you multiply the beginning and the end by 5. So we are 0 to 1800 degrees. It's a lot, it's 5 rotations. So now we're looking for the sine of what is equal to 1. Well, sine is positive 1, only right there. So it's once a rotation, so we're going to have 5 answers. So 90, 90 plus 360, 450, plus 360, 810, plus 360, 1170, plus 360, 1530. Then you go back and you divide them all by 5. If when you divide by 5 you get a decimal, please write the decimal. 18 degrees, 90, 162 degrees, 234 degrees, and 306. And then, of course, that meets our requirements of being between 0 and 360.